Hello everyone, welcome to Legacy IAS. So this is our weekly current affairs for science and tech. Okay, now I have picked some news that are from PIB, and after that there are some more news that came in Indian Express and The Hindu that we'll be covering today. There are a lot of topics, so we'll move quickly. Okay, now first thing is this parliament question. As you know, parliament session is going on. So there are many questions that are being asked by opposition parties and other parties, and to answer them, government is telling a lot about what are the developments that have been done in various sectors, and that is why this question came. So parliament question came on Gaganyaan mission and Bharti Antariksh station. Okay, so they have here in this article they have given details of what we have achieved till now. Now this is first about Gaganyaan mission. Now if you see, so there are different components of it. In different components we have achieved some things. For example, if we talk about this human rated launch vehicles, okay, so what has happened? Development and ground testing of all propulsion stages and structures completed. You understand what is this human rated launch vehicle? So basically, if we are sending a launch vehicle, okay, and to send some people from Earth to the space, now it has to be human rated, as in it must be able to provide environment for human survival, and that is called human rated launch vehicle. For that we have to do a lot of testing, and that is what is being done here. Then there is something known as orbital module. So there are two modules, one is crew module, one is orbital module. Orbital module is which will take it round and round. Okay, so what it has, so it has the propulsion system that has been tested and qualified. Then it has ECLSS, which is engineering model for environmental control and life support, that has also been realized. Then there is crew escape system. So what can happen, that in situations where let's say you are going for a launch and some issue is caused in it. Now otherwise usually what happens, that satellite or payload is lost, but here if we are not able to save it somehow, then we will be losing lives, and that cannot be allowed. That is why we have some things known as crew escape modules. So crew escape modules become very important. What they will ensure is that in any issue, crew should be able to escape successfully or safely. Then there is infrastructure, of course, that's needed. Gaganyaan control system, crew training facility, all this. Then there are various tests that has been conducted. Okay, right now prelims is little far. Okay, but still you try to remember these tests. Again, you will find an updated one near your prelims. So please try to remember, because this is a very probable question that they ask, that which of the following tests have been completed for Gaganyaan, because Gaganyaan mission's test being completed becomes a separate news each time in the Hindu, Indian Express, all this. Okay, so these are the tests that has been completed till now. Then flight operations and communication network, crew recovery operation, all this has been achieved. Some are in the planning stage, some have been envisioned completely. Okay, so completely modeling, engineering modeling of it, and some test also we have conducted. The exact precise details that you remember near your prelims, but right now what you need to understand, what are the different parts and where we are trying to, what we are trying to do with respect to Gaganyaan mission. Then then you should know about this Vyom Mitra also. So what we are doing, this is a half humanoid. So this is a lady looking like robot, and what this can do is basically this can sense any changes in the environment. So that, because humans, let's say you might have traveled in flights, now you might have seen that if the pressure drops, now when the pressure drops, then also, or if the pressure increases a lot, your ears start to pain much later than what the flight should be getting instructions for. Correct? So flight gets all these details much before you. Now to have the same things, because if we just send humans and humans start feeling certain issues there in the space, so before that there should be something that is able to identify those issues before human being starts to feel it, and that is what Vyom Mitra does. So everything that human does, okay, or human feels, it will feel it with a much high sensitivity, and it will be able to tell us that the temperature is completely changed now, the pressure is changed by this point something Pascal, everything it will tell. Then Next, it talks about operationalization of Bharati Antariksh Station. Okay, what is Bharati Antariksh Station? So basically, what we are trying to develop is basically we want our own space station. That is Bharati Antariksh Station. Right now, the target is to get there by 2035. Okay. Now, ISRO has worked on the overall configuration of Bharati Antariksh Station comprising of 5 modules. This has been done. The budgetary allocation of 20,000 crores approx for this has been approved by the cabinet. Then, this detail you don't need, but what you need is, if you are writing means you have to write that we are also collaborating with other agencies in these 2 missions. And what are those agencies? This is European Space Agency, this is Australian Space Agency, this is Russian Space Agency Roscosmos, and CNES or European Facilities. Okay, this is what we are collaborating with for Gaganyaan as well as Bharati Antariksh Station mission. Now, this is an interesting one. Okay, first we need to understand the technicalities of it, then we can see the factual part. Now, Parliament question was application of radiation technology for agriculture and food security. So, what they have done, this is by Department of Atomic Energy, not Department of Science and Technology or Department of Agriculture. So, understand it carefully. Now, what they are doing is basically they are irradiating, let's say, fruits and vegetables with some kinds of radiations, and because of that we are able to get certain good properties in those fruits, vegetable, or whatever we are putting that light on. Now let's understand how this entire thing works. First, what you do is basically, so this bark, which is Bhama Atomic Research Center, they have developed 72 improved varieties in different crops using radiation-induced mutagenesis along with crossbreeding. Now, what is mutagenesis? That you understand first. So, what you do? You will expose the seeds or cells to some kind of radiation, X-ray, gamma rays, very strong radiations. Now, what will happen? These radiations are strong enough so that they will damage the DNA. The DNA of these products will be damaged. So they will be slightly damaged. Now, what will happen? DNA has a self-repair mechanism, correct? That whenever DNA breaks from somewhere, it actually copies some codes here and there, and then it will join back together. Okay, so it has a self-repair mechanism. Now, when the DNA is joining back like this, it tends to create errors because this process is a little imperfect. Now, this imperfection will help us actually. So this imperfection will lead to formation of completely new mutation or variants. Same tomato and some new variant we have created. Now, of course, the variant can be anything. It can be even worse, that it is not even growing in size now, or what can happen that the sweetness of the tomato is gone. All that is also possible, but don't you think the other side is also possible? That because of some mutation, what we can get some desirable traits. That maybe what ripens the tomato faster, that part of the DNA is also destroyed. So now that tomato can be there can have a very long shelf life, and this is what we are doing here. So we will screen for selective fruits, and then whatever qualities we got from them, then we will crossbreed them. Okay, so crossbreeding will occur between 2 good traits, one, and after this crossbreeding, what we will get? We will get the progeny or the next generation which will have both of these good qualities. So you're understanding, we are not causing genetic changes using DNA fragments, CRISPR, this, that, nothing. It's a very simple phenomena, irradiating light, damaging the DNA. Okay, and then observing that can we get a good mutant out of it. That is the whole process. Now if you read it, you will understand everything, nothing much. Some of the desirable traits of these crops. What are the desirable traits? All these can be done through different experiments. Higher yield, seed size, early maturity, climate resilient traits like drought, heat, salinity tolerance, resistance to diseases. All these are possible. Correct? Then it talks about the Department of Atomic Energy. Now, usually we don't associate Department of Atomic Energy with agriculture and all this, but it has actually undertaken various initiatives to promote adoption of improved crop varieties in Indian farming communities. To promote this, DAE, Department of Atomic Energy, is actually collaborating with state seed corporations, okay, state agricultural departments, Krishi Vigyan Kendras, farmer cooperatives, FPOs, okay, this you read about in economy. So all this, they are collaborating. Then they're also going to Kisan Melas, field days, all this DAE is doing. Now, DAE has developed radiation-based food preservation and food processing technologies to reduce post-harvest losses and extend shelf life of agri products also. So here what we were focusing on, we were developing certain crop varieties that were much better in all these, much more climate resilient, okay, would mature early, will have a bigger seed size, all that we were doing. Now, in post-harvest also, we are doing the similar things using radiation. In post-harvest, what is the most important thing? Now, it does not have to grow, correct? It does not have to fight climate, this, that. What is the most important thing in post-harvest? This was a question in mains this year. That what Indian farmers are doing to prevent their perishable crops or to protect their perishable crops. Now, one thing that has to be done here is increasing the shelf life. That is the main thing with respect to post-harvest losses. 15 to 20% of whatever India grows with respect to food crops is actually lost in spoilage. Post-harvest, we are having these many losses. So what can be done? So basically it can increase the shelf life of agricultural products. Then the technology has been transferred to private entrepreneurs on non-exclusive basis. Non-exclusive basis, so that whatever they want to commercialize, whatever they want to do, they can do through licenses. Then Government of India is also putting this whole thing that I explained you under Pradhan Mantri Kisan Sampada Yojana, where we are developing cold chain infrastructure. This is something similar. It can extend the life. Now, in Uttar Pradesh, 3 food irradiation facilities have been commissioned even till date in the private sector. Correct? So, a good technology, simple to understand, and also it has a lot of advantages. Correct? You're not doing all those difficult changes in DNA, CRISPR, nothing. Very simple but useful technology. Then in DAE, again it talks in agriculture, DAE is constantly taking initiatives and sending these different kinds of crops, sometimes different ways of protecting the post-harvest crops, all this to agricultural universities and ICAR Institute. Then next topic is about semiconductor and AI revolution. Okay, so there is very less to understand in this topic, but because this was a PIB backgrounder and there are a lot of important schemes and initiatives that government has launched for them, that is why what has happened, you have to remember a few things from this. This is a very probable mains question. Okay, next, this year we have not seen anything with respect to semiconductor in mains. Okay, it's very probable you will see it then. Now, semiconductors, I think you would understand what is a semiconductor. That is not conducting fully or not stopping the flow of current fully. Correct. So basically these semiconductors are like switches. These are like small switches, very useful in making chips. Okay. So these are the foundation of modern technology, powering everything from smartphone, vehicles to satellite and AI systems. AI is not now accelerating the demand for advanced chips. Correct. That is why you might have seen the demand is so high that the rates of laptops and everything has risen. And if you are buying the laptop at the same price, let's say 40-50,000, then the quality of chips that you were getting earlier has reduced. Why? Because this demand is huge. Okay. Then now, so this you understand. Now what India is up to. So India is trying to build domestic capabilities across semiconductor value chain, from chip design and fabrication to advanced packaging, equipment, materials, everything. We want to do it end to end. Okay, India want to achieve end to end proficiency in semiconductor. That is right from the start to the fabrication of chips and deploying them in different fields. Everything we want to do on our own. Then dedication mission laid the foundation of self-reliance. Then it talks about the mission, okay. Basically, Semicon 1.0, you might know about this, 76,000 crores was the outlay, and they were able to establish 12 semiconductor projects here. Okay, now, right now we are in Semicon phase 2, Semicon 2.0, and the approved outlay, you see here, 1,27,500 crores. That amount of sum has been outlaid. So you can understand how much government is focusing on this. This is huge. This is huge money. Okay. Then, so out of these 12, 3 have also commenced commercial production. Then, now semiconductor facilities will supply critical components for automobiles, telecommunication, aerospace, power, all this you understand. So in all different fields, you need chips. These chips will be provided by these semiconductor facilities. Then developing indigenous semiconductor design. So there are two schemes that you need to remember. One is chip to startup. Okay. This is from end to end, from chips to startups. Everything is covered here. And the other thing that you should remember, we also have one of the other topic that is based on this. This is design linked incentive scheme. Okay, this detail we will see later in just the next topic. So these two schemes are also related to semiconductors. Then there is electronic design automation. Now, what are these? So basically these are softwares that are used to design, stimulate, verify, optimize semiconductor chips. Seven chips of around 12 nanometer, this has been designed. So basically, so anything that is like 12 nanometer, okay, this is called an advanced, not extremely advanced. Extremely advanced is like 3 to 5 nanometer. So this is still an advanced chip that we have started successfully fabricating. Then it talks about global partnership. So almost with every country we are collaborating. Whatever country you like, okay, from the US bloc, you can write. We are collaborating with all of them. Okay. Now, then India AI mission. We have talked about this a lot. Okay. So basically this had an outlay of 10,000 crores. And here also we showcase that what we are doing in artificial intelligence, and we also got a lot of funding for projects of foreign companies, but that will be based in India. Then sovereign AI capabilities, if you remember Sarvam AI, okay, all that we have done. We have reached 45,000 plus GPU units as of June 2026. Correct? Then GPU, I hope you understand. What is a GPU? Graphic processing unit. Now understand this. For example, see, if I want to make a photo, now I want to generate a photo. Now, don't you think, let's say you're trying to draw my face here. Now, if you start with my eyes or you start with my teeth, it does not matter. If you are able to draw me well, then I'm satisfied that you have drawn my good picture. I can't even tell by looking at a picture that which part was drawn first. Correct? This is something that can be done simultaneously because order does not matter here. If order does not matter anywhere, then what you can use is graphic processing units. That has very small cores and it can process everything all at once. Correct? Now, the opposite or the earlier version that we had for processing was of CPU, central processing unit, which used to do things in order, that is sequentially. So for sequential tasks, CPU is still good, but for tasks that requires dividing it into many parts and then solving them or doing them independently simultaneously, then what you need is GPU. And the entire AI, this, that, LLM, everything is based on this only. Parallel processing is what it is called. And this is what GPU is very good at. Understood? Now, we are also developing foundational AI models, digital backbone, okay, from laboratories to real world governance. So all these, any of these, if you remember, you can put it in points. in mains. Now, this is quotable. That is, we are opening various center of excellences. So, we have opened 58 artificial intelligence center of excellences across India. Then, building the talent and deep tech ecosystem. Okay. Then, trusted AI alongside rapid adoption. Okay. Then, expansion of data center. So, we now have installed capacity of around 375 megawatt in comparison to earlier 157 we used to have 375 megawatt in 2020. Now we have 1575 megawatt capacity right now. Then next it talks about global recognition. Both of these points can be quoted in mains. First, the Stanford Global AI Vibrancy Report. Now, what it does, it ranks India third globally in AI competitiveness and ecosystem vibrancy. Remember this, very good. You can quote this very easily. Stanford Global AI Vibrancy Report 2025. India is ranked third. Fine. Then next, in 2025, India was the second largest contributor to GitHub AI projects. Okay, which shows that India's strength is in its developer and innovation community. Again, you can quote in mains. This one is very good to be quoted in mains. Then India joined. This is again something that was all over in news when during the India AI Impact Summit. Okay, now what is this? So Pax Indica coalition that US has, we have joined it officially. Okay, so we'll be working with other partners to strengthen resilient global silicon supply chain, because right now it is mostly China which is leading in everything. Then this is what we want through our all these initiatives, that is sustaining momentum in chips and AI. Okay, why PIB backgrounders are good? If you see all these PIB articles, whatever was important is covered in this, and that is why I tend to pick more and more of PIB backgrounders. Okay, then again, important topic. Why important? Because recently in last 2 years we have seen, and this year especially, they have started asking what India's private sector is achieving in science and tech also. Like in 2026 itself, they asked about India's one private company that was able to make first 3D printed rocket. Okay, Agnikul Cosmos. Okay, then in mains they asked about Mission Drishti, which was not a government scheme, government project. It was actually a satellite mission by a company called Galaxy that is based in Bangalore. Then they also asked about in prelims about different semiconductor fabs and packaging centers that has been started or commenced in India or proposed in India. Now, those were also given to private sector. So it had name like Tata, Simsek, all this. So you're seeing that they are focusing on what private sector is up to also now. Why so? Because government has recently opened some very important sectors to the private participation. For example, space was opened. Correct? All this is post-COVID. Then nuclear is also now opened through that Shanti Act. That's why all this becomes important. Okay, now let's see this. So this is saying that whatever you have to remember is given here only. We'll see the details, but try to understand it here only. Now, what it says? It says DLI scheme backed chip design startup Ahisa Digital. So Ahisa Digital, first of all, this is a company. Okay, this is a private company. What they have developed? They have developed first pass silicon success. Okay, so basically what they have developed this Vihan chip. Now, what is a Vihan chip? This is a broadband chip that is built using indigenous Vega microprocessor. Now, what is this Vega microprocessor and Vihan? Now, Vega microprocessor is indigenously built microprocessor, like we talked about Dhruv 64. Similar is this Vega microprocessor that we have made. Now, this is indigenously built. Now, understand Vihan. So, what is Vihan? Now, see where it lies. So, you see here broadband chip. Now, till now, India is largely dependent on foreign partners for getting these broadband chips. Now, where are broadband chips used? Understand that. So there is fiber cables through which your internet connection is that this you understand. You also understand your router and Wi-Fi, and you also understand from your router or Wi-Fi, basically you are getting internet on your phone. This flow everybody understand, but don't you think fiber cable has that data? Correct. Now, do you think really that everything is going back to the servers and then it is getting decided? Okay, do you think everything is going back and then it is getting decided? No, it has to process a lot of data. Correct. Now that is actually done by chip that is in between. So basically there is Vihan chip right here after the fiber cables, and here processing of high speed digital data occurs. High speed digital data is processed here and then it is sent to your router and Wi-Fi, and this keeps on going. So this is where it lies, and this is where we were dependent. Like we are still dependent, but we have developed something indigenously. So this is what India is focusing on, that we want to become as Atmanirbhar, as independent as possible in every domain. Now that you understand it, now it becomes a factual topic. So what is Vihan? So Vihan aims to bring fiber broadband to Indian homes and has attracted VC funding from various different corporates, including Tamil Nadu Infrastructure Fund Management and Corporation. Now, again, two things are still left. One is understanding this. So this is a DLI schemed backed chip design startup. Okay, so DLI scheme backed chip design startup. So design linked incentive that we understood. So basically you are getting incentives based on the new designs and everything that you develop. Now, this is backing this AHISA Digital. So one thing this you have to remember, other is a very good data that you can again quote in mains, written here, quote in mains, which is DLI scheme backed companies. You might know about PLI, production linked incentive, similar is this design linked incentive. Okay, so DLI scheme backed companies have cumulatively raised over $100 million in VC funding. Now, why this is important? See, DLI scheme is backing them, but VCs, that is venture capitalists, which are independent in their own, correct. Now, if they are also investing their $100 million in it collectively, that means the scheme is backing the right companies which are showing right results. Then only these VCs are investing in it, and that is what they want to show using it. So what you can say is basically all these schemes that government does with respect to funding in any way is always wants to promote private funds also to be put in that same companies or in those same initiatives. Everything government cannot fund, but government funds it to show that support and confidence in certain companies, and that is why this is important. Everything else is factual. So semiconductor design, semiconductor value chain. So semiconductor chip design contributes up to 50% of overall value addition in that entire chip. So designing is 50% of it. Then, so design linked incentive is supporting Indian startups for chip wide range of strategic and commercial applications. Commercial and strategic applications, you may understand. What are the applications of any chip? Everywhere, from artificial intelligence to aerospace to communication drones, surveillance, defense, okay, Internet of Things, telecom, smart meters, whatever. In every field you can see this. Then, now, AHISA is what? So it is Indian fabless semiconductor startup that designs chips for broadband networking and security. This we have understood. Then, so this is a networking system on chip built for fiber broadband, will now proceed towards production tape out targeted for 2027. So now this has been designed. Now it will come for the production. The target is 2027. Let's see when it comes. Now, as India expands its digital infrastructure through optical fiber, 5G broadband, then it becomes very important. The need for domestically designed semiconductor solution is growing, and that is why we came up with this. Then next is it shows investor confidence, as I explained you. Then government support helping Indian chip companies move from ideas to product. Correct. Now there are few more. Okay, just read them once. Okay, just read them once, and if something strikes you, okay, just before the exam, then you can do it, because they have given match the column of semiconductor fabs that are based on, that are of private sector only. Government is funding or supporting it in a very different ways, but it is largely private sector. So please try to remember this also. So there is very semi microelectronics, which has developed some motor controller chip. Okay, then there is Nitra Semi, which is 12 nanometer vision SoC. Then there is OptoML. Then there is Mind Groove Technologies. Okay. Then there is IndySimac. Okay. So all these are there. Just basic names. If you can remember some, it's fine. Otherwise, most probably if they ask, they should be asking about this Ahisa Digital and Vihar, because this was a proper article in PIB. Then chips designed in India are now being fabricated, tested, validated, prepared for customer trials. Everything is being done in India, which is strengthening our supply chain. Because if everything is done in India, then nothing like it. Correct. Then now there are two topics that we have to see other than the PIB. One is this humanoid robot sprint. Now, what is this? So you might have seen that there was recently the second, this I am trying to draw a robot, okay, because it looks like human, so you might feel that I am drawing a human only. So what they have done is they actually carry out race between robots. So these robots run like humans, they look like human, they run like human, everything they do like humans. Now why it becomes important? So you might think that why are we making robots run? Correct. And now recently what they are saying that China's Tiangong Ultra robot ran 100 meter in 9.39 seconds, which is faster than Usain Bolt. 958 Usain Bolt is a champion, you might have heard. Okay, so basically it has beaten Usain Bolt in 100 meter running. Similarly, this lightning robot has done this in 9.47 seconds. Also this lightning robot, it actually fainted after covering it. Okay, after completing the race, it completely fainted and had to be taken on a stretcher, just like an injured human. Okay, so now why we are doing this? Some people might question this. Like there were also jokes and memes around it that what is a robot that is faster than human, and people were writing car. Correct, because car is also a machine that is faster than human. Then why we are making this? Now let's understand, because we are students of science. Okay, you're doing UPSC, fortunately or unfortunately, now you're a student of science. So let's try to understand why all these nations are trying to or competing in this. Why is it important? So why do engineers teach robots to run and compete? Now understand that many things that we as humans do are actually far more complex than you can imagine, far more complex than the mathematics and whatever questions and all this you do, answer writing. You think that I am doing something very intellectual, but those are very mechanical things. The simple things that you do, for example, if you're walking and the floor is not plain, and because of that you sidestep sometimes, then using your other leg and sometimes hand, you push yourself and somehow balance yourself back. Now that happens within less than a second. Correct. Now how your brain interprets all this, that this is the slope, this is how I have sidestepped, this is how I have to control, this leg I should place now, this leg I should place little strongly, and hand should be here, and hips I should move like this, and then I can balance myself. This requires a lot of ability. Now if you have to encode this in a robot, it requires a lot of qualities all at once. Everything it has to do on its own within that fraction of a second. And that is why making these humanoid robots becomes so difficult. So first understand why they are trying to teach this. So sprinting solves multiple mobility problems at once. Correct. Suddenly you are going this way, that way. Sometimes they are also making robots that can climb mountains. All this they are doing. Robots must accelerate, balance, react, decelerate. Okay, it replicates complex human biological reflexes. Then this mimics how humans instantly catch their balance. The games also test everyday tasks like carrying items. Correct? Like carrying items also. Like sometimes you might have seen that whenever, a very basic example, whenever you pick up a bucket that is filled with water, you raise the other hand also. Correct? To balance. Correct? Now, if you are falling on one side, then also you are somehow balancing it. So all those are dynamic decisions that your brain takes. So that is what they want to make with robots also. They have successfully made. They will try to make it better and better. Now, understand why this is important. Once we go in detail, you will really see that what capabilities it gives you. Now, how will these physical capabilities be used in real world? Now, there is everyday assistance. Now, you want robots to clean your houses. You might have seen this in movies that I want robot to come clean my house, cook for me, bring me something, correct? Might have seen this. Now, for that, you need what? You need human understanding that this part is clean. Here I should put my hand. Now my hand won't go. Now I should use my leg. Now, whatever all this, all those variables, how it will be able to do when it understands motion in a human way or understand mobility in a human way. So robots will have to clean houses, they can deliver food, all this will be done by them. Now, this is very important. This, I think US is also working on it, and this is a very, very important use case of whatever they are doing in this Olympics of robots, whatever. Now, this is a very important thing in disaster relief. For example, you might have seen that a building catches fire. Now, because of that, a lot of people lose their lives. Correct? There were incidents in Old Nagar also where a few students unfortunately died. Correct? Because of waterlogging. Now, all these issues, what was the main cause? That no human could enter there and save them. Correct? There was no possibility that any human can enter in a building that is all caught in fire. But if a robot is made, now we have materials through which we can make robots that can sustain fire. Correct? We have fire resistant suit also. Correct? So very easy to make. Now, the most difficult part will be that how this robot is able to climb through the stairs of the house, how it is able to locate that this is the front door, how it locates the knob, how it opens this door, how it gets to the person that is frightened or shouting, or look for that person, then find that person, how he grabs him, how he saves him from the nearby fire, how he takes him down like this. Correct? For that, he needs to understand human like mobility, and that is why in disaster relief this can be a game changer. So they can navigate rubble, stairs, fires. Robots can shut off dangerous walls, so it can go inside. Maybe it is caused because of gas cylinder leakage. Correct? So it can go and first turn off the gas. Correct? Then they will help rescue trapped people. This I have explained you. Military use cases, yes. So ground robots will navigate unpredictable terrain. They carry heavy military supplies. They will work alongside soldiers in hazardous zones. Correct. So number of soldiers required will be lesser. Also, this is much safer to carry. For example, if your military is has to carry some important things from one place to another. Now we have to use soldiers, and sometimes we know that the path is not so safe, but still we have to take the risk. But if we have robots like this, then they can carry on. Correct? Then, what does this mean for new global AI race? Now, so global AI race, one with respect to the AI that we understand as LLMs, okay, or agentic AI. All that goes on. But apart from that, we want to bring this artificial intelligence and robotics into the physical world also. And if we want to bring them to physical world, all this becomes very important. Okay, then we come to the last topic, which is NASA moon base program. Now, what is happening here? Understand. So what is NASA's moon base program and its phased roadmap? Now, so recently NASA has called ISRO to join its moon base program. So it aims to establish sustained human and robotic infrastructure on the moon. So this is the aim of NASA moon base program. Over long term, they want permanent infrastructure on the moon. Correct? Now, it focuses on lunar south pole to utilize water ice for fuel and life support. So what they have identified, that there is water ice or water in the form of ice in the lunar south pole. This they will be using to sustain life there. That is the whole plan. Now, this is a phase timeline. Okay, so phase 1, that is 26 to 29, will be secure, reliable lunar access, conduct surveys and test equipments. Then from 29 to 32, this is phase 2. This is where they will build energy grids, communication, logistics and surface vehicles. Then there is phase 3, which is post 2032. Here the aim is to establish a permanently human operated outpost with expanded habitats. So permanent habitat we want to develop, or USA wants to develop. Now, because this is a program that sort of takes humanity forward, so that is why it is inviting other institutions, other space institutions also, and NASA has invited ISRO. Now, how do the Artemis Accords relate to this mission? So the Artemis Accords set the principle for peaceful and transparent space exploration. Correct. India also joined this in 2023. Now, signing the Accords does not automatically enroll India in NASA missions. Okay, so India is not bound by Artemis Accords that now whatever NASA does, we are also a partner in it. Nothing like this. In fact, signing the accord does not mean that we have to be part of every lunar mission of NASA. Nothing like this. Then, actual mission participation requires separate specific agreements. Okay, so right now they have just invited us, and it is not like we are bound or we have to enroll. There is no other option. Nothing like this. Even though we have signed Artemis Accords. Now, then there are two sides to the coin. First is understanding why should India participate in the program. Then we'll also understand what are the concerns if we join it. Now, there is support national roadmap. So it accelerates Gaganyaan, Bharti Antariksh Station and Moon 2040 goals. We also have goals now. So it is aligning with them. Whatever we learn there, all the technologies and all the frameworks of how to work these models with respect to Moon will be used in our Gaganyaan, Bharti Antariksh Station, Moon 2040 goals, everywhere, correct? Then ISRO will gain deep space habitation, docking and mobility experience without starting from scratch, correct? So we were not part of International Space Station when it was made. Now we have shown docking capabilities recently in 2025 and 2026 through SpaceX missions. Now, but if ISRO wants very good experience of space habitation, docking, mobility, all this we can gain from this. Correct? For example, recently we also sent Sudhanshu Sharma to go into the International Space Station, then come back. It cost us a lot of money. Now, and that was only a 4-day trip. Now, we can have long habitations, docking, mobility if we join the program. Then economic and industrial advantage. So basically it shares high emission cost and avoids technological duplication. So whatever they are doing, anyway, they are much more advanced than us and we don't have to spend that much cost to gain the same insights. Then Indian private companies can enter global supply chain in robotics and AI. Correct? Because some suppliers we will get from India also. Then terrestrial spin-off. As I always talk about in science and tech, one point you should always mention is spin-off technologies. Then lunar research advances, water recycling, correct? Because that small amount of ice, water, whatever is available, that they will be recycling and using it for the entire infrastructure. That will develop some kind of advances in water recycling, energy storage and materials on Earth. Now, when all this is developed, same thing we will try or we can try to deploy on Earth as well. Correct? Then what are the key concerns and strategic challenges for India? One is technology dependence. So excessive reliance on US technology could risk our long-term space autonomy. Correct? In the long term, we may not have that much space autonomy. So we should not completely rely on US. Rather, what should be our approach? That we observe strategic autonomy. That we have ties with NASA, but it should not disrupt our ties with Russia, France, Japan, all this. Then limited tech transfer. Collaboration does not guarantee access to sensitive or proprietary technology. So if we are not getting those proprietary technology or anything, we should not be giving our own also. Then governance issues. Unresolved international laws exist around lunar mining and operational zones. So this is an issue, correct? Because it is not completely resolved what can be done, what cannot be done. So those are the challenges. What is the recommended way forward? Simple. adopt a collaborative, learn and indigenize framework. Collaborate, learn. After learning, what we have to do? We have to indigenize these systems to be used in India's mission. Okay. Then maintain the core operational principle, which is interoperability without dependency. Interoperable with NASA, but not having dependency on NASA for everything. Then cooperate internationally while preserving the independent capability to explore space. So we must collaborate, okay, with different countries and, for example, NASA here, ESA here, but we must have our own independent capability to explore the space, and that should be our aim. Understood? So with this, we are done with all the 7 topics that we had to cover for this week's current affair. That's it. Thank you.